When someone asks you who is your mother, you will answer with one single name. In other words, we can say that the question who is your mother is a function that will return a singular answer every time it is used on any person. For example, Fatiha has two sons, Ayman and Faisal. With Ayman as the input, we will get Fatiha as the only output. The same goes with Faisal. However, the inverse question, who is your son, is not a function for Fatiha because there can be two outputs, Ayman and Faisal. A function must have only a single unique output for each input. Let's go through a few terms first. An element is a fancy name for a thing in mathematics like the number 4 or a tape. A relation is a connection between two elements. For example, there is a relation between 3 and 7 and between you and your mother. Note that elements can be abstract things like the color of an object. A function is a special relation where an element is mapped to exactly one element. More formally, each and every input must have one and only one output. This means two things. Each input cannot have no corresponding output, and each input cannot have more than one output. In other words, each input must have exactly one output. A function can be illustrated using an arrow diagram. Two elements can map to the same element. However, a relation that maps an element to more than one element is not a function. An object is an input for a function, represented by the lowercase x, and an image is an output of the function, represented by the lowercase y. The set of all possible objects of a function is called the domain, capital X, while the set of all possible images is called the codomain, capital Y of the function. Given a set of objects, the range of a function is a set of images that can be mapped by the objects. Note that the range is part of the codomain in this case. Functions are usually represented by the notation y equals f of x or f maps x to y. Confused? Let's try an analogy. Imagine a magical fruit machine that will turn any fruit you insert into a fruit juice. If you insert an orange, you will get orange juice. If you insert a watermelon, you will obtain watermelon juice. Although some non-mathematicians will call such a machine a blender, the magical fruit machine behaves similar to how mathematical functions would. The magical fruit machine represents a function where the fruit is an object and its corresponding juice is an image or the result of the objects being inserted into the function. The domain is a set of all possible fruits you can put inside the blender, while the range is their corresponding juices. The codomain in this case includes possible juices you cannot get from blending, such as coconut juice. You can't blend coconut using this function, a blender. To make coconut juice, you need another function. You will learn through your studies a bunch of different functions, ranging from simple ones such as linear equations to functions such as binomial distribution. We can categorize functions into discrete or continuous functions. Continuous functions are functions that accept a continuous set of objects. For example, all polynomial equations, including the linear equation, which can accept values of any whole number or in between. Discrete functions are functions that accept specific objects. For example, the blender from earlier, which only accepts fruits, and there is no fruit in between a watermelon and an orange. There are also discrete mathematical functions too, like counting the number of ways to arrange X people in a line. Surely you can't arrange 7.5 people, and you can't have 2.3 ways of doing it. Functions can be mapped onto a Cartesian plane. For example, the function fx equals to 2x plus 1 could be mapped by plotting the value of y for each x, with x acting as an object and y acting as the image. Through this, you can easily determine the image of any object by tracing its value on the x-axis to its corresponding value at the y-axis. For example, the image of 2 is 5 in this graph, and the image of 3.5 is 8. A vertical line test can be used to determine whether an equation is a function. First, plot the graph on a Cartesian plane. Then draw vertical lines on the plane. Observe if any of the lines intersect with the equation more than once. If all lines have at most one intersection, then great! The equation is a function. However, if any of the lines intersect with the equation more than once, the equation is not a function. This is because the vertical line indicates the input, the number of intersections indicates output. If there is more than one intersection, there is more than one output for an input, and thus it is not a function. To recap, a function is a relation where each object maps to exactly one image. It is this requirement that defines functions and gives them interesting properties that are useful in solving problems both in mathematics and in the real world. Is the altitude of the sun a function? What about the number shown when you roll a dice? Comment below if you know the answer. Stay safe and see you next time.